Hello, my name is Seth Moyer, and the topic I chose to explore for my independent project is the applications of the parallax effect in 3D rendering and animation, specifically in its ability to help quickly generate architectural visualizations. The reason I was interested in this project is its ability to speed up scene building by not requiring extra scene modeling and development. The parallax effect is a displacement in the apparent position of multiple objects viewed along two different lines of sight. By using multiple layered 2D elements layered throughout the foreground moving at different speeds to a fixed camera position, one is able to create fake 3D immersive environments out of multiple 2D elements. This technique has historically been used in web design and film animation but has recently been introduced into the architectural visualization field. This effect is very powerful because it has the ability to reduce model file sizes and render times. The earliest origins of parallax and parallax animation can be seen through the invention of the multiplane camera that was invented in 1930 by UBI Works, who was a famous animator and director at Disney. The camera works by allowing animators and designers who work on the film to arrange multiple layers in different positions in a vertical column with a camera pointing down at them in a fixed position to create the illusion of a 3D immersive world. This allowed animators to generate worlds that had depth and immersion to them rather than the traditional 2D environments. As a result, the technical effects that the multiplane animation camera introduced were an unprecedented leap forward in the field of animation and a big step forward in the digitalization of the parallax effect. The next case study I would like to introduce is a company called W Parallax, which focuses on creating and selling parallax interiors for architectural visualization. The company uses a new method that allows you to take a single polygon and project an entire room or 3D space onto it. The company uses open shading language and a script called JWindowBox to create realistic fake interiors with the click of a button. This effect is often used in video games to optimize scene performance, and their goal is to bring it into the archviz industry. They offer packs of interiors from offices to retail spaces and other categories you might need to quickly visualize without the need for time-consuming modeling. In addition, parallax technology has also been incorporated outside of the film and architectural industry and into UX and web design. Websites and companies use a method called parallax scrolling, which is based on multiple layers coming together and moving at different speeds to produce the optimal illusion of 3D space while using 2D assets. This technology has been applied to website design for multiple reasons, but some include improving user engagement of the website as well as creating a stronger interaction between the users and the seller's products. One company in particular that is utilizing the effect is a company called Engineered Floors. Their company focuses on creating sustainable flooring products to sell to their consumers. On their website, once the visitor starts to scroll, the visuals that represent a particular product zoom in and create a more vivid preview of the product for the visitors. In this way, the company applies the technique of parallax to create a strong interactive website that helps them to better market and sell their products. After looking into the history and current applications of the parallax effect, my resulting thesis question became, how is the application of the parallax effect transforming architectural visualization and animation? To start the process of exploring 3D parallax and its application to 3D rendering, I chose to use SketchUp combined with D5 Render, as they would allow to both utilize 3D geometry and multiple file types within one render engine. In this process, I was unfamiliar with using 3D parallax within a render engine, so my first step was to create a base model in SketchUp in which we could place the parallax interiors. For this, I created a simple urban scene with multiple planes of glass in the facade of the building that could be utilized to experiment with the parallax interiors. Once the scene was finished modeling, I imported it into D5 Render and started to initially utilize the default parallax interiors that come with the program. After I understood how they worked, I started to create custom parallax interiors within Photoshop that could be UV mapped to a single surface then brought into D5 Render. As D5 does not currently support the process of bringing in non-native parallax interiors, I had to work around the program and import them by saving the files from Photoshop as an FBX file. Then once inside of D5, I imported those files in a custom alpha as a PNG. Once the custom parallax interior were positioned into the glass facade, the rest of the process was creating custom materials and setting up the final animation settings. As a result of my research into the history and recent applications of the parallax effect, the project allowed me to further explore another tool and process within 3D rendering and animation that I was unfamiliar with in the beginning of the process. In addition, it helped me to gain knowledge in custom UV mapping techniques and advance my knowledge in architectural visualizations, allowing me to create my final animation.